we take a look at the sample problem. So it says when you look at the North Star, okay, 就是北极星或者叫做 Polaris Polaris. You intercept light from a star at a distance of 431 Ly. Ly is light year, light year 就是光年嘛 light year, okay, and emitting energy at rate this number times that our sun P sun neglecting the atmosphere absorption 就是大气的那个吸收嘛find the RMS value of the E electric and B field when the starlight reaches you, OK， 所以就是问这个北极星北极星，那给出它的半径嘛，也就是说来到地球时候的那个球面面积你就会知道，然后也告诉它源头的那个功率源头的那个 energy energy at rate rate 就是 dPdt 嘛，也就是一个能量的一个能量 ，OK， 它是比或者应该是反过来了，能量应该是 dudt 是等于一个 p， 就是能量在对于时间的导数是那个功率，那功率是比太阳大很多倍了，大2000倍。OK， 然后就问你来到地球的时候，这个电场磁场各是多大？那北极星的话，其实在地球看就是很接近那个正北的方向，所以你在地球的绝大部分地方你看到都是在北面，所以它叫北极星。Okay, so here we have I equals PS over 4 pi r squared. Just use the formula in the previous page. And also we have ERMS square over C mu naught. Okay, so we have these two formulas to be equal to each other. And then also we know that this R, okay, we actually need to convert this light year back to the SI unit. Okay, so that it should be 431, okay, and then times 3 times 10 to the 8th power. So this is the speed of light times how many seconds in a year. So it will be roughly 3060 seconds in an hour, and then 24 hours per day, and then times 365.25 days in a year. Okay, so you may say, some year we'll have 365, some year we have a leap day, so we have 366. So that roughly every 4 years we have a leap year. So it's around 365.25. Okay, actually a little bit smaller because for let's say 2000 years we don't have this leap year. Okay, if you still remember. But actually roughly 365.25. Okay, so this is actually 4.08 times 10 to the 18 power meter. Okay, so that's why we usually use light year to represent the distance in the space. Otherwise the number will be really large. Okay, so based on this equation, we can try to have ERMS equals to something. So we try to move this part to the left side and then take the square root. So we have a PS C mu naught over 4 pi r squared, and then take the square root for the whole thing. So we have this is PS is 3.9 times 10 to 26, and then times 2.2 times 10 to the third. Okay, so this is the power of the sun, and then this is how much times the P of the North Star larger than the sun. Okay, so this is the P P of the North Star, the power of the North Star. And then times C is 3 times 10 to the 8th power, and then times mu naught is 4 pi times 10 to negative 7th. Okay, and then all over 4 pi, and then r squared is 4.08 times 10 to the 18th power quantity squared. And then we take the square root of this big thing. Okay, so finally, this number is 1.24 times 10 to negative 3rd. Okay, you can use volt per meter, or you can use N over C, Newton per Coulomb. Okay, it just depends on what you like. Okay, so this is ERMS. So finally, BRMS will be ERMS over C. So this is 1.24 times 10 to negative 3rd power over 3 times 10 to the 8th power. So this is 4.1 times 10 to negative 12 Tesla. Okay. Okay, so next we talk about the radiation pressure. Okay, so this is a kind of particle characteristic of the EM wave， 就是那个电磁波的粒子的特性，所以它有所谓的压力或者是力，这个有点像那种动量守恒的那种感觉，动量守恒。Okay, so here it says, when a surface intercepts EM radiation, a force and a pressure are exerted on the surface. So if the radiation is totally absorbed by the surface, the force is this one. Okay, so we have this F to be, this is the intensity multiplied by the cross-section area over the speed of light. Okay, and then so for this case, this is totally absorbed. Okay, so which means that if we have some EM wave, okay, shoot to surface, okay, and then this is totally absorbed. Let's say this is a black paper. Okay, so it will absorb all the light, all the EM wave. Okay, so totally absorbed. So then there will be a force, okay, acting on this surface. Okay, so for the second case, if the radiation is totally reflected back along its original path, the force is 2 times larger. Okay, so it's 2 times larger. So in this case, if there is a beam shooted to a mirror, okay, a mirror, and then this wave is totally reflected. Okay, so this force is IA over C, and then this one is like 2IA over C. Okay, so this is like conservation of momentum. Okay, so this stuff has some sort of momentum, and if it is totally absorbed, okay, so we have this force. But if it is refracted, okay, so which means that for the conservation of momentum, okay, so this is like we have P here, we have a P here, and then here we have also P, but in opposite direction. So this term should refer to 2 times of P, so that the total final P should be, the final momentum should be conserved. Something like this, okay. And then it also defines something called radiation pressure, okay, the force per unit area. Okay, so this is nothing but the PR is defined by F over A. Okay, so F over A. So for this case, for the total absorption, okay, move this A to the left side, so it is I over C, and then for this case, 2I over C. Okay, nothing special, just some definition. Okay, actually, just try to tell you that the EM wave also, or the light also have some have the characteristic of a particle， 就是动量啊，动量这个东西啊，是一个粒子的特性嘛，动量就是一般古典力学的话 ，P 等于 mv 嘛，啊 P 等于 mv， 那就是一个东西要有质量啊，要有质量，要有速度，或者要速度，它才会有一个动量。但是一个电磁波啊，它是一个 wave， 如果单纯是一个 wave 的话，它不应该有这个特性啊，它不应该有动量的特性。但是实际上它有，就是它就是比如说你用一个射灯开一个射灯的话，你站在它的附近的话，你会感觉到那种射灯射过来的那种力量，就是那它还是有那个光子的特性，但这个就是它就是为了说那个故事就是古典物理跟近代物理嘛，近代物理的一个转折就是在1905年以后嘛，就是那个包括那个光电效应，还有这个狭义相对论，从1905年到1915年啊，然后那个时间还是那个狭义相对论跟广义相对论发展的那个10年啊。那在后面10年的话，就是那个量子力学，在1915年以后。Okay, so actually next we talk about the polarization. Polarization. So in Chinese it's called 极化，极化。Okay, so EM waves are polarized if their E field vectors are all in single plane, called the plane of oscillation. Light waves from common source are not polarized, that is, they are unpolarized or polarized randomly. Okay, 你可以叫做 polarized 就是极化，或者是叫做另外它的相反叫做 unpolarized。或者叫做 randomly polarized， 就是随机的极化，这是没有极化的意思，就是哪个方向都有。Okay, so here is this figure shows what does it mean by so what is a polarized EM wave, which means that we only have, let's say, vertical polarized E field. Okay, and of course at the same time we will have the B field oscillating along the z-axis. Okay, so but here when we talk about polarized, we only consider, let's say, the E field. Okay, if all the E field are oscillating along the one axis, okay, can be vertically, can be horizontally, can be in any angle, okay, to the z-axis, but only one direction. We will call it polarized. For this case, okay, so if there are many different angles of the E field oscillation, so we will say this is unpolarized or polarized randomly. Of course, you can try to collect the, let's say, the z-axis component, y-axis component. So then finally we have we try to combine all these into this z-axis component and y-axis component, so that these two components are perpendicular to each other. 就是你还是可以把这些归起来全部都当做水平跟垂直方向的。那但是两个方向都有的话，它就是没有极化啊，就是 non-polarized unpolarized 或者是 polarized randomly. Okay, so here we have some interesting formula. Okay, so first it says if the original light is initially unpolarized, the transmitted intensity I, okay, the intensity I is half of the original intensity I0, okay. So I0 is the intensity for the original one. Okay, so after going through something called a polarizing sheet or some polarizing filter, 就是一些就是滤波器的感觉，就是 So here we have some vertical lines, so which means that only vertical polarized component can go through. Okay, all the horizontal component cannot go through. Okay, so after so for the incident light, it is unpolarized light, and then after going through this polarizing filter, which is vertically polarized. Okay, so the output ray will be vertically polarized. Okay, and then the intensity of this one will be half of the original one. Okay, so this is what this equation tells us. Okay, and then here if the original line is initially polarized, 就是来的已经是 polarized. Okay, the transmitted intensity depends on the angle theta between the polarizing direction of the original light and polarizing direction of the sheet. Will be this one. Okay, so this I0 is the original light, but it is originally but it is already polarized. Okay, 但这个 I0 跟这个 I0 不同，这个情况是进来的是没有极化那输出经过之后就会变成一半。那这个是原来是有极化的，那这个 polarizing filter 跟它原来极化的方向有一个角度 theta， 那输出的那个 intensity 就是原来的 intensity 乘以 cosine 平方 theta。OK， 因为它有 E 跟 B 了，所以两个 cosine， 所以这边有两个 cosine 是存在。而且它是算那个 E 嘛，那它是算 intensity 的话是有 E 平方，所以这里会有一个 cosine 平方。Okay, so here we have a sample problem. So let's see what it says. Okay, so the figure shows a system of 3 polarizing sheets in the path of initially unpolarized light. Okay, the polarizing direction of the first sheet is parallel to the y-axis, that of the second sheet at the angle of 60 degrees counterclockwise from the y-axis, and that of the third sheet is parallel to the x-axis. Okay, what fraction of the initial intensity I0 of the light emerges from the 3-sheet system, and in which direction is the emerging light polarized? Okay, so at the beginning, okay, we have this one I0, okay, coming from top right, okay, and then here we have one polarizing filter, okay, which is vertically, which is placed vertically. Okay, so only vertical polarized light can go through. Okay, so this I1 is vertically polarized. Okay, so let's see. So it says before sheet 1. Okay, so the light is unpolarized. Okay, so we have an intensity I0, and then we can somehow denote it like this. Okay, so this is unpolarized. Okay, so after going through the sheet number 1, okay, so this is already polarized. Okay, and then the intensity I1 will be half of I0, and it is vertically polarized. Okay, so here we have, this is the first one, this is the second one, and then we still have a third one. Okay, so after the sheet number 2, okay, so this one is not vertical. This one is 60 degree counterclockwise to this y-axis. Okay, so in such a way, the output wave going through the second one, which is I2, so it is also polarized. So I2 will be I1 times cosine of theta. This theta is 60 degree. So cosine square of 60 degree. So which is 1/2 of I0, and then times cosine of 60 degree, cosine of 60 degrees is 1/2, okay, 1/2, so 1/2 squared. Okay, so this is 1/8 I0, okay, for I2. And then finally the third one, this is horizontal, this is horizontal polarized. Okay, so which means that this one and this one will have a 30 degree between them because it is a 90 minus 60. Okay, so it will be 30 degree between this one and actually this is, okay, so this one is 60 degree. Okay, so after the final one, the sheet number 3, it is of course also polarized, and then the I3 will be I2 and then cosine square of 30 degree. 30 degree. So I2 will be 1/8 I0 and then cosine of 30 degree is square root of 3/2 and then quantity square. Okay, so this final one will be 0.094 I0. Okay, so this will be polarized along x-axis. Okay, which is somehow like along x-axis or horizontal polarized. Okay. Okay, so next we talk about some simple thing. I think some of the content have already been covered in high school physics. Okay, so here we talk about the reflection and refraction. Okay, 就是反射跟折射. Okay, so yeah, so here we have the law of refraction. Okay, which means the angle of reflection E equal to the angle of incident. 就是入射角跟反射角是一样的。那这个算法是跟那个法线的夹角。Okay. So we have a theta 1 equals to theta 1 prime, okay? So actually in this graph, okay, we have the incident, we have the incident ray here, okay? So this is the incident angle, angle of incident. And then this is the angle of reflection, reflected ray. Okay, so we have a theta 1 equals theta 1 prime, okay? So this is the law of refraction, 就是反射的定律。And then we also have the law of refraction. Okay, 折射的定律是叫做 Snell's law. Snell's law. Okay, so here we have n1 times sine of theta equals n2 times sine of theta 2. Okay, so what is n1 and n2? So n1 and n2 is a core index of reflection. 就是一个叫做折射率吧的东西吧，指数啊 ，index 是指数，但是好像平常好像叫折射率。Okay, so how does it define? Okay, so actually this n is defined by the c divided by v. Okay, so this is the index of refraction for a material, and this c is the speed of light in vacuum. Okay, the speed of light in vacuum 真空的光速。那这个就是 speed of light in the material， 就是因为其他任何的物质的光速都会比在真空里面来得慢所以就是 C 除以这个就是定义为那个物质的那个折射的系数那这个数就一定会大于1的一定会大于等于1 OK， 那真空的话跟空气会差不多，真空跟空气会差不多。那其他的物质的话就 N 会相对比较大一些，所以就会有比较明显的折射现象比如说水啊、玻璃啊，或者是其他的钻石啊什么的。So that is associated with the medium involved in the reflection. Okay, so actually for the stainless law we have this N1, N2, and then theta 1, theta 2. Okay, so actually you can check it on the figure. So theta 1 is still the angle of incident, and then this theta 2 will be the angle of refraction, also counting from the normal line. Okay, so this is the boundary. This is the boundary between two material. Let's say this is air, this is water. Okay, so this is the normal line. 就是这个是发线，就是垂直那个点的那根线。OK， 所以入射的话是从发线算到这里，以 theta 1。那折射的话也是从发线，不过在另外一边算到这里是 theta 2。Okay, so here we also have something called a chromatic dispersion. Chromatic dispersion， 这个叫做色散光的色散。OK， 就是色会散开的意思。OK，of bright light， 就是大家都知道的嘛，就是普通的光经过玻璃就会变成一个彩虹嘛，或者是或者是钻石也会，或者是水晶或者也会产生折射现象，或者是有时候就是大气的水汽也会产生嘛。Okay, so it says the blue component is spent more than the red component. It spent more than the red component.OK， 所以这个是为什么红绿灯要用红灯来做一个停止的意思，就是红色的话就是折射会比较少 ，angle 会比较少，那它就比较能传得远一些，传得比较远一些。它的意思是 bent more。Bent more。What does it mean by bent more? Bent more means Okay, so here, of course, this is the air, this is the glass. Okay, so this is the incident light. Okay, so if you just ignore, there's a boundary between two material. So of course, this line will go in a straight line. And actually, bend more means this angle is larger than this angle. So we will say that the blue ray is bending more than the red ray. OK， 那反过来也是类似的，就是如果这边是力，这边是苏的话，就是蓝色的话也会转的比较多，转向比较多，这个是叫做 bent more。那 bent more 的话，就是它就是比较会转到一个不能传播的方向。那红色的话就是转的少，它折射之后的转角比较少嘛，那就会一般情况下就会传的比较远。但这个图就是有点夸张的，实际上的话就没有差那么多，就是。Okay, so we also talk about something called the total internal reflection， 就是叫全反射全反射，那大家应该都学过了。So total internal reflection means, so according to the law of reflection, we have n1 times sine of theta 1 equals n2 times sine of theta 2. Okay, so we can somehow rewrite Okay, so it can be like sine of theta 2 equals sine of theta 1, okay, times n1 over n2. N1 over n2. Okay, so here let's assume if n1 is larger than n2, which means n1 over n2 is larger than 1. Okay, but what we know is that sine of theta should be between sine of theta 2 should be between 1 or -1. Okay, at least for real number of theta. If it is a complex number of theta 2, then sine of theta can be larger than 1. Okay, but here we only consider real number. So in such a way we need to satisfy this one. However, this one is larger than 1. So which means that if theta 1 is large enough, theta 1 is large enough, then this whole thing can be larger than 1. Okay, in such a way we cannot really find theta 2 such that sine of theta 2 is also larger than 1. So what does it mean? So here n1 is larger than n2, which means that this one has a larger index of refraction, and then this one has a smaller index of refraction, so that this angle should be larger than this one. Okay, so if this theta 1 is large enough, okay, or at least some point, if theta 1 equals to theta c, which called the critical angle, such that this whole thing will be 1. Okay, so this is the maximum incident angle, such that the output ray can be defined. Okay, so this is 90 degree, this is 90 degree, and then corresponding to the angle of incident will be theta c， 就是这个叫做临界角。Okay, so if the incident if the angle of the incident is larger than theta c, then there will not be no refracted ray. All the ray will be reflected. Okay, 就所有都会被反射。那如果是小于或者等于 theta c 的时候，是会部分折射、部分反射的。但这里就不会算多少是折射，多少是反射。如果是学电磁学的话，就是真的比较进阶的课的话，就会推这个这些怎么去极化的，就会很麻烦的，很麻烦。Okay, so this one is called the frustrated total internal reflection， 就是我也不知道中文叫什么了，反正 frustrated 就是很沮丧的意思，就是很沮丧的全反射。OK， 很沮丧的全反射。那什么意思呢？ Now, so this one, okay, so I don't try to go through this text. If you have interest, you can check. But here it means that if we have this prims， 就是有一个棱镜啊，有一个45度、90度的棱镜，有两个。如果我们有两个，我们把它们分开，我们把它分开一个比较大的距离，然后这个棱镜的那个 index of refraction 是比较大的，所以如果45度进来的话，它会全部都反射。因为这个90度嘛，所以这个也没有偏转。那这边它会大于那个临界角，大于那个 theta c， 所以全部都反射。Okay, all the rays are reflected. Okay, if we try to, so skip the first. Okay, so we go to here. If we try to combine these two prims together, okay, so it's like there's a boundary, but this gap is really narrow to be somehow like zero. Okay, 就是你把两个45度的棱镜拼在一起， 那这个界面的话就等同不存在。那整个光速的话就是这边没有偏转，这边当成没有 boundary， 它就是直接就过去了，这个就是 no reflection。OK， 那左边是全反射，右边是 no reflection。OK， 现在这个 frustrated 那个沮丧的全反射是干什么的？就是我们把这个两个棱镜，棱镜就是留一个很窄的缝隙。OK，so leave a gap, leave a small gap between. Okay, so airframe is made to thin out by progressively squeezing the springs together harder until they make intimate contact. 就是你用一些方式就是去让这两个棱镜它中间有一个很窄的一个缝隙。OK， 它就出现神奇的现象，它就会有部分会反射，部分会通过部分会通过。这个其实有点那个量子力学的意思，就是它会穿过一些东西。那当然这个学期我们不会讲这个量子力学，时间来不及，或者是对时间来不及。但是它有点像那个叫做 tunneling effect。那你有兴趣的话，就是可以看一下，因为我 po 在 Moodle 上面，就是38章的内容 tunneling effect， 就是叫做串隧效应串隧效应，就是它就是比较跟古典力学比较不一样的地方。简单来说，这个 tunneling effect 就是说，平常比如说我们古典力学的意思就是一个物件，如果它的位能比中间的位能墙来的小的话，它就穿不过。就比如说，我中间有个墙你有一个人在这边我有一个球那中间有个墙的话，就是它等于说这里有一个位能的墙就挡在前面。那你要把球穿过去的话，那怎么办？那你要把球丢过比它高的地方，就是比如说你要有一个很大的动能，把它转成这个球的位能把它丢得很高。那这个 U of 这个球就要比这个 U 来的大，你才会丢过去。如果你丢那个球的动能不足以让它转成足够大的位能，这个 U 比 U 小的话，那你就打在墙上反弹回来嘛，就会过不去。那实际上的话，就是量子力学这个 tunneling effect 的意思是说，如果我建立了一个位能的墙，但是这个粒子它的能量、它的动能是比这个位能墙来的小的话，它会有概率是小部分会通过去会通过去，然后有一些会弹回来，有一些会弹回来，有一些会穿过去，它就会有一个概率做了这个动作，就类似是这样，就是如果离得很远的话，那全部都会反射，就会像这边就会有个 standing wave。如果没有的话，它就完全能通过去，全部都通过去，就跑到后面去。但是如果这个很窄的话，就是有一些它会反射回来，有一些它就会很幸运的过得去很幸运的过去，这样。所以这个有点量子的现象存在。那有兴趣的话可以去看一下。Okay, so here we have a table about the refraction indices. Okay, so for the vacuum it's exactly 1, and then for the air it's a little bit larger. 1.000 1.029. Okay, a little bit larger than 1. And then for the water, 1.33. Okay, and then you can also see, let's see, yeah, for the typical glass around 1.5. And then here, okay, for the diamond, 2.42. Okay, so yeah, so that's why ladies like the diamond very much. Okay, so yeah, so it has a very large refraction indices. Okay, so to make it very shiny. Okay, yeah. Okay, so here let's have a